All right, IBSL1 gang, welcome back. Today we're going to finish off 2.5, the composite functions. Remember, the functions within a function. Our first example, they don't give us the equation or graph or anything like that. They just give us these coordinate pairs from f of x and g of x. So f of x is represented by those 4 coordinates and g of x is represented by those 5 coordinates. Then they ask us to find f of g of negative 2. The first thing you need to think is that a negative 2 is getting inputted into the g function. So if you find where negative 2 is in the g function right here, that means if you input a negative 2, you will get an output of positive 3. So another way to view this is that you are trying to find f of positive 3. So what just happened? A negative 2 went into the g function, and then a 3 popped out of it as an output. But now that output has become an input for our f function. So if you find where in the f function there's an input of 3, there's an output of positive 4. So this whole thing is just 4. So you can do these compositions of functions lots of different ways, like if you have the equations, if you have coordinate pairs, if you have tables, if you have graphs. The next example is if we have this graph. I see that the pink line here is f of x and the green line is g of x. So our first task is find f of g of 2. That means I need to figure out what output is going to be associated with 2 is going to be associated with an input of 2 on the g function. So if you go to the g function and then trace where x is equal to 2, so I'm going to do some dots up. Here, let's zoom in. The g function, don't care about f at this point, but right here, this, I'm assuming, is an output of 3. So what I'm really trying to find is f of 3, because I put a 2 into g and out came a 3, but now that 3 needs to become an input of the f function. So if I find where 3 is, oh, this is going to be boring. So here's 3 on the x-axis, and then you trace it up to the f function, and then trace it over, I will get another output of 3. Lame example, book. That could have been way more spicy. So this whole thing is equal to just 3. The next one, right here, gof of negative 1, g of f of negative 1, means I need to put negative 1 into the f function. So, negative 1, why did they make this graph so small? I don't understand, but negative 1 is right here. And if you, let's get real in there, trace it up to the f, we're doing f, right? Yeah, f of negative 1. That means it's an output of positive 1. So what we're really trying to find is g of positive 1. Zoom in here to positive 1 and go up. Oh, really, book? Is it halfway in between or something like that? Hold on, let me check the book. Should have accounted for this. Yeah, it's 2.5. Man, these are awful examples, you guys. I really shouldn't trust the book sometimes. So we're guesstimating that's 2.5. So this whole thing really shouldn't have to guess. What if it was 2.4 or something? I guess I could figure out what the slope and all that. Anyway, last example. Maybe it'll be a good one. Also, I want to get rid of these guys right here. G of 0. So first, we need to figure out what output is associated with an input of 0 on the g function. So if you go to 0 on the x-axis and trace it up, that means 2 is an output for g when 0 is put in. Now, you're going to take that output and feed it back into the g function. So now we're trying to find what output is associated with an input of 2. Here at 2, if we go up, I think we established earlier that this is 3. That problem could be way better. Last problem, life insurance rates. So here's this master function, C of n equals $1.25 times 2017 minus n. N is going to be the year a person was born. C of n is going to represent your monthly insurance rate based off of your age. The first question says decompose. So anytime you take multiple functions and cram them all together into a new function, you're composing functions. Now they want us to decompose. It's like take it apart and find the little individual functions. There's lots of ways to do this, but when I look at this, I think the most simple way to view it is that this is $1.25 times something, and that something is 2017 minus n. So really there's two parts to this. Let's say, what do they use? F and G? Sure. F of n is equal to the age part of it, just the inside. So that's just the inside up here. And then G of n is $1.25 times n. So if you were to multiply these two functions together, you would get the big cost function. So I guess I could write that C of n is equal to these two functions multiplied together. No, not multiplied together, composed. C of n is f of n inside g of n. So this is goff of n, according to this f of n and this g of n. Don't like those highlighter colors. Explain what each component represents. Well, f of n represents somebody's age. And g of n is $1.25 for every year you've been alive. Is that the right way to say that? Yeah. How much will life insurance be for someone born in 1968? So for this, let's just use the master formula. So 1968 into $1.25 times 2017 minus 1968. So if you take 2017, which I'm assuming is the year this problem was written, and subtract 1968, that means the person is 49. Then multiply that times $1.25. So every year they've been alive, you have to pay, like, the older you are, like, the more life insurance costs. So $1.25 times that 49 means that this person is going to pay $61.25 for life insurance per month, which is actually not bad, I think. Now, Manuel pays $41.25 per month. In what year was he born? Well, first of all, he's not paying $61.25, so I can tell you that he's not 49. He's going to be under 49. They are giving us an output of the master function. So, $41.25 equals $1.25 times 2017 minus n. First thing I'm going to do, you could distribute the $1.25 to here and here and then start solving, but instead of doing that, I am just going to divide both sides by 1.25. So 41.25 divided by 1.25 is 33. Now 33 is Manuel's actual age, but that's not what they asked us to find. They asked us to find what year he was born. So if we subtract 2017 from both sides, we're going to get a negative number on the left, but that's good. 1984 equals negative n. So divide both sides by a negative, and you get 1984 is equal to n. So 1984 is when Manuel was born. Another child of the 80s, just like me. I have many friends that were born in 1984. It was a good year. All right, guys, that's it for composition.